layer 2 QoS, here that is our traffic, right? 4 was free.
Yes, sir.
So if I will talk about IPP, so we have 8 bits in the toss. 5 bits are reserved and 3 bits are used for QoS. Out of 8 bits, 3 bits are used for QoS. Combination was 0, 0, 0. Then 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, and 1, 1, 1. Right? This was called IPP 1, or I am saying P1.
Yes, sir.
Precedence value 1.
Routine, sir. Routine.
Yeah, name of precedence value 1 is routine. Routine. Here, then
Priority, sir.
then हमने ये P0, this was P0. Okay, then P1
Priority.
precedence 1, name was priority. Precedence 2
Immediate.
Precedence 3
Flash.
plus. Precedence 4
Flash override.
Precedence 4 plus override. And precedence 5
Critical for voice.
Critical.
Critical for voice.
Critical for the voice traffic. And in the DSCP, this is only called EF. Then precedence 6 is called internet.
L3 routing protocol.
Yeah, internet L3 protocol, or you can say internetwork controller also. Sometime in some books you will see name is internetwork controller. And precedence 7 was network layer protocol, or we can say network or network controller. This was my 8 IPP. IP precedence value. Clear? याद है ना?
Yes, sir.
This is what? 8 IPP value, precedence value. So we can categorize traffic in 8 parts. And some was reserved, right? This is reserved for layer 2 protocol. This is the default one, best effort. This one is default, best effort, correct?
Correct.
Means no priority. If no priority is configure. If you are going to capture any normal traffic, you will see IPP value is 0. Precedence value is 0. After that, priority was not reserved, immediate, flash, critical. Critical was reserved for voice, right?
Yes. Critical is for voice.
For layer 3 protocol, L3 protocol, like your EIGRP, OSPF, and this was reserved for L2 protocol. Right. So if I will talk about the free IP precedence values, so see P1 is free, P2 is free, P3 3 is free and P4 is free, right? We can use it to prioritize our traffic. We can give precedence value P1, P2, P3 and P4 to the traffic, right? You can configure these precedence value according to your requirement. Critical is reserved for voice. P6 is reserved for routing protocol like EIGRP, OSPF, BGP, right? HSRP, FHRP, all the gateway availability protocol. P7 is reserved for all L2 protocol, STP, VTP, DTP, whatever L2 protocols we have. And we have 4 precedence value for uses. And higher IP precedence value means higher priority, right? So let's say I have 3 types of traffic: telnet, SSH and HTTP. And I want to define priority in this way only, in this sequence. Telnet should have priority over SSH and HTTP, then SSH should have priority over HTTP, and then HTTP should have priority over all the general traffic. Right? So here to the telnet I can define what? Precedence value 4. P4 I can define SSH to P3, HTTP to P2, and all general traffic to P1. This way we can prioritize the traffic. But issue is, if we have more than 4 types of traffic to prioritize, then we can't. Right? So that's why we come up with DSCP. We have seen in the yesterday class. DSCP. Again, in the DSCP we have 8 bits.
8 bits.
8 bits. Total
Yes,
IPP is also 8. 4 are reserved, 4 are free to use. So DSCP is nothing but the replacement of IPP. Number of bits are exactly same. In the toss to the DSCP, we have 8 bits only. Issue with IP precedence is we can only categorize 4 types of traffic. Many types of traffic cannot be categorized, like telnet, SSH, HTTP, HTTPS, SNMP, POP3, right, and so on. FTP, TFTP. So if I have so many types of traffic, we can not categorize it. And DSCP is solving the issue. In DSCP, how many AF value I have, guys?
So 8 bits are there. 3 are our 2 are our ECN bits.
Out of 8 bits, 4, 5, 6, 7, 8. Out of 8 bits, first 3 bits are called class selector. Second 3 bits are called drop probability, and last 2 bits are called ECN.
Yeah.
Explicit congestion notification. In the drop probability, again this bit is
Reserved.
Right? So in the drop probability 2 bits are free, and in the class selector 3 bits are free. So with the help of combination of class selector and drop probability is called AF. You know this. Combination of class selector and drop probability is called Azure forwarding. And again, by using these 3 bits, you will have
8 combinations.
8 class selector. How many class selector I will have? 8. Like class selector 0, class selector 1, class selector 2, class selector 3, class selector 4, class selector 5, class selector 6, and class selector 7. Class selector 0 is
000.
routine. Default one, routine. Class selector 1 is called
Immediate.
Here we call it permit. Okay, you can
Okay.
call immediate as well.
और priority.
Permit.
या priority है. सर हमने कल priority करके लिखा हुआ है, same ही लिखा हुआ है.
यहाँ पे 1 में
हाँ, वन में.
permit. This is called immediate. Immediate. Flash override.
या flash and flash override.
Immediate flash over. क्या हो रहा है कीबोर्ड में? Flash override. Critical.
Voice.
L2 L3 internetwork. Internetwork controller or network. Control. This is my class selector. 8 class selector. Again, this is either for L2 protocol, this is either for L3 protocol, this is either for voice, this is either for best effort default. So class selector 1, class selector 2, class selector 3 and class selector 4 are free to use.
Yes.
But again, with the help of class selector, we can only categorize 4 types of traffic.
Correct.
So we are not directly going to use class selector here. What we'll do, we'll combine drop probability here. So how many drop probability are there? 2 bits are there for drop probability. 2 bits drop probability. So value can be either 0 0, 0 1, 1 0 and 1 1. These are my drop probability. Here I can say what I can say D1.
Best effort वाला.
Yeah. Low drop.
This first वाला best effort था, then low drop, then medium.
This is best effort. That default one. Effort, then low drop, medium drop, and high drop. And high drop. Right, and combination of drop probability and class selector is called EF. And we have calculated 12 numbers of EF. EF1, EF2, EF3, EF11, 11 to
13,
then 21 to 23, 31 to 33, 41 to 43.
3,
And EF41 will be always before our
F42,
42. EF42 will be always before our EF43.
3,
And EF43 will be always before our EF31
31.
and so on. Right, we had already discussed this. Correct. So now we can categorize traffic into 12 parts. This is more than sufficient. Generally you will not have 12 types of traffic in the network. 4, even 4 was sufficient. So this is Azure forwarding. These values are used to prioritize the traffic. And after that, guys, in the DSCP we have EF also. EF called EF is your 46 DSCP value, the
Just
critical
express
one,
forwarding, I think.
101. Yes, correct. Then we had seen the convergence. Remember convergence?
नहीं सर, कन्वर्जेंस नहीं डिस्कस किया हमने।
नहीं, कन्वर्जेंस मतलब कि IPP टू डेसिमल कन्वर्जेंस, ये वाला
या
डिस्कस किया था,
या हाँ हाँ हाँ, करेक्ट।
right? And in the AF, see, two things are there. CS means class selector and drop probability. High CS class selector means more better, high priority, and drop probability is just opposite of class selector, right?
यस,
That's why we are saying AF41 will be before our AF42, and EF will be always before our all the EF will be
ओके।
always before our all the EF as you are
So what
forwarding.
would, sir, what would be the value then? 101, and drop probability will also be there in EF?
000.
000। सर फिर भी अपने पास 8 ही हुई, 2 बिट फिर भी रहेगी।
नहीं, ये एक अकेला EF होता है,
ओके।
ये जो हमने क्रिटिकल के लिए डिफाइन किया हुआ है ना, उसका,
P5।
या उसका है ये 46 होता है, 46 डेसिमल वैल्यू। कैसे
ओके।
होता है देखो, EF के लिए जो बिट्स होगी आपकी 101 एंड
करेक्ट।
110 होगा, ये होगा 6 बिट्स, जो कि हमेशा किसके लिए हम यूज करते हैं, वी ऑलवेज यूज इट फॉर वॉइस।
This 110 is drop
ड्रॉप
probability।
प्रोबेबिलिटी, यस।
Okay। All bit 1, that means high drop rates,
हाई, देखो
and
क्लास
0 0
सेलेक्टर में
0।
हमने जो EF कैलकुलेट करने के लिए यूज किया क्लास सेलेक्टर, वो सारे नहीं यूज किए ना, ये क्रिटिकल वाला नहीं यूज किया था,
जी।
राइट? तो क्रिटिकल वाले को आप कॉम्बाइन करोगे ड्रॉप प्रोबेबिलिटी 1 के साथ, तो आपका क्या बनेगा, EF
ओके।
ऐसा होता है, ठीक है? सो ओके, आई एम एक्सपेक्टिंग दैट these are clear to you, these are completely theory part. Now let's talk about practical, how we can configure quality of service. So, and one more thing we had discussed, that is quality of service models. It works on 3 models. Best effort means first come first out, first in first out, FIFO. Then we had seen integrated service model,
Used
which
by
was working
ISP।
on per flow by using RSVP protocol, resource
Correct।
reservation protocol. And the last one is diff serve model,
Bit of
differentiated serve model, that we are going to use. Just putting a, it is like diff serve model is, diff serve model is like putting a signal on ambulance, symbol like that, means on the traffic we are putting the signal to prioritize it, right? For ICMP traffic I can put the priority, for different types of traffic we can set the priority, right? On this is a path, here we are not configuring QoS, right? Instead of reserving the bandwidth, we can mark the traffic. Here we are not reserving the bandwidth, any bandwidth. It's work on per hop basis by checking the marking. Like in this case, if I will configure QoS on router number 2, router 3 will forward the traffic on the basis of that marking, which router 2 will perform. If I will perform the marking on router number 1, these all routers will forward the traffic on the basis of that marking throughout the path, right? Now guys, if I will talk about the implementation of QoS, so see, you need to configure how many things there. First of all, classification. We had discussed this also in the last class. Classification means which traffic to mark. which
Marking.
ट्रैफिक टू मार्क, कौन से ट्रैफिक को मार्क करना है. देन मार्किंग. मार्किंग मीन्स which bits to mark or what marking you want to set, what AF value, IP precedence value you want to set. Getting my point? Which
AF value.
bits to mark or what marking you want to set. What marking AF or EF DSCP value, decimal value you will define now. That's why I'm saying bits here. What
Okay.
marking you want to set. After that, configuration. Configurations. How we will perform classification and marking. For the classification, I will configure what? Class map.
Class
Step
map.
1. Step 1. Create class map for classification. Create class map for classification. So step 2. Step 2, marking. For the marking, what we'll do, we'll create policy map. Create policy map for marking. Right? And then finally in step 3, we need to apply it on the
interface.
Right? So step 3, apply it on interface. Apply on interface with the help of service policy.
Correct.
With the help of service policy. We'll apply it on the interface. Guys, classification will happen on ingress interface. On which interface? Classification will happen on ingress interface, on the receiving interface.
We can say LAN interface.
Yes, you can say LAN interface. Or here on router number 2, if I am configuring QoS, so on F0/0, what will happen? Classification. Means router will classify the traffic there. Classification happens on ingress interface. And marking, when router will perform marking while forwarding it from the egress interface. Marking happens on egress interface. अब देखो समझाता हूं. This is my topology. Okay, what I want between 1.1.1 and 4.4.4, if it is telnet traffic, then router should set any IPP value. Let's say what? 4. IPP value, IP precedence value 4. It should set IP precedence value 4. So router is going to identify the class traffic when it is going to receive out in the interface. When router will receive it on the interface, it is going to classify. And when it will forward the traffic from this interface, at that time it will perform marking. So that router 2, 3 and 4 can forward traffic on the basis of marking, on the basis of marked. Getting my point? So this is the point which you need to always keep in mind, that my classification will happen on ingress interface and marking will happen on Marking will happen on egress interface. Clear? Now we can see the configuration. First of all, guys, in this lab, what I will do, I will configure any routing protocol to make reachability between 1.1.1 and 4.4.4. You tell me which protocol you want to use.
OSPF करेंगे सर.
OSPF? ठीक है, OSPF configure. Config the interface loopback 1 IP address 1.1.1.1 255.255.255.255. Exit interface F0/0 no cert and IP address 12.1.1.1 255.255.255.0. Exit router OSPF 1 router ID 1.1.1.1 and network 1.1.1.1 wildcard 0.0.0 area 0
1. Okay.
and network 12.1.1.0 0.0.255 area 0. Go to router number 2, config the interface F0/0 no cert IP address 12.1.1.2 255.255.255.0 interface F1/0 no cert and IP address 23.1.1.2 255.255.255.0. Exit router OSPF 1 router ID 2.2.2.2 and network 12.1.1.0 0.0.255 area 0 and one more network, that is 23. Done. Now I am expecting OSPF neighborship here between router 1 and router 2. Till then, let me configure R3. Interface F0/0 no cert IP address 23.1.1.3 255.255.255.0 and interface F1/0 no cert IP address 34.1.1.3 255.255.255.0. Exit router OSPF 1 router ID 3.3.3.3 and network 23.1.1.0 0.0.255 and area 0 and one more network, that is 34. OSPF का neighborship कम अब क्यों नहीं आ रहा है? अच्छा यहाँ पे आ गया है. ठीक है. On router number 4 interface F0/0 no cert IP address 34.1.1.4 255.255.255.0 interface loopback 1 and IP address 4.4.4.4 255.255.255.255. Exit router OSPF 1 and here I am configuring router ID 4.4.4 255.255.255. Exit sorry router ID
4.4
router ID 4 and network 4.4.4.4 0.0.0 area 0 and network 34.1.1.0 0.0.255 and area 0. Now I can capture any link between two routers to show you the default priority for routing protocol here. Let me capture the link between router 2 and router 3. I'm going to capture this link. Okay, here is the hello message of OSPF. Let me open it and let me open IP header. See, this is hello message of OSPF. I'm going to open IP header, and in the IP header you can see class selector is 6. Same class selector is configured here 6 for L3 protocols or even IPP. Both are compatible with each other. Okay, if you will define the IPP, it will automatically convert it into DSCP class selector. So you can see as it is layer 3 protocol, by default priority is configured over here. Even guys, while sending the packet also you can prioritize the traffic. See, if I am going to ping 4.4.4 from 1.1.1, topology is clear. Here is the topology you can see. 1.1.1 is running on R1, 4.4.4 is running on R4. If I am going to send ICMP packet ping 4.4.4.4 and source 1.1.1.1, ping is working, and here is my traffic. Is there any priority? 0,
No,
0 you
0
can
is
see.
default.
Default. What happened? Caption गयो. अब देखो. While sending the traffic also I can prioritize the traffic. When I am pinging 4.4.4.4 from 1.1.1, at that time also I can set the priority. I can set the IP precedence or DSCP value. See, now I am going to ping. I am going to use extended ping. Okay, ping and enter. It is asking about the protocol. It is IP target IP address 4.4.4.4 and repeat count. Let's say 1. I am just sending one ICMP packet. Data size is 100. Fine. Timeout is let's say 1 second. I want to use the extended feature. Source interface is going to be what? Source 1.1.1.1. And now it is asking for what, guys? Type of service. Here you can see toss. If I will say toss 192, then what will happen? What class selector it is going to set for 192? 192 means (128 plus 64). What will be the value? 192. 192. Right? So 1, 2, 3, 4, 5, 6. This is going to be my bits.
CS class
Yes.
selector. Yeah. 110.
Class selector ये होने वाला है ना?
Correct.
Class selector should be this one. So let me send this ICMP packet with 192 and don't fragment bit, leave it, send it. Now here is the ICMP packet, right? Now if I will open this ICMP packet, you can see, open the IP header and see the DSCP, see the class selector. Got it?
Yes, sir.
110.
0.
So I have defined the toss value. It have automatically converted into class selector DSCP. It is using class selector 6. So while
So why it is using DP?
DP?
Drop rate. DP में it is using 00. Default 1. मतलब best effort. Drop probability में. इसमें 110 then 000.
हाँ तो ड्रॉप प्रोबेबिलिटी है अभी 00 ही यूज करेगा इसमें 00 ही ड्रॉप प्रोबेबिलिटी का हमने आईपी प्रेसिडेंस दिया है ना सिर्फ ये क्लास सेलेक्टर यूज कर रहा है
Okay.
राइट सो while sending the traffic also I can set toss value. Only toss value is there I think in the ping. Let me check again. Ping IP target IP 4.4.4.4 repeat count 1 size fine timeout fine extended no sorry extended में तो ऐसे आया ही नहीं इसमें yes करना पड़ेगा toss ही है ना IP 4.4.4.4 repeat 5 size okay yes source 1.1.1.1 and type of service is there only. If I want to set let's say IP precedence value 5 or override 4 IPP 4 this one or class selector 4, what should be my decimal value? Now you tell me.
Sir 100 तो 128 होगा sir.
128. So if I will say here 128, right, and here is my caption.
Yes.
Fine.
Class selector 4.
Clear? So
Sir,
yeah,
we set the value 100 on this router number 1 or 1.
128.
Yes. So
Yeah,
if
so
you check
router
it,
1 is marking, na?
uh,
Router
so
1
if you,
will perform marking on their exit interface. And here
okay, sir.
is the capturing between router 2 and router 3. So we
Even
are
if you
able,
check between R3 and R4
yeah,
also
yeah,
same value.
anywhere, yes. Till
Okay,
the
okay.
destination, this traffic
Okay,
is
okay,
going to be prioritized.
okay, sir.
1 minute, guys.
Bro, this we are capturing the link between R2 and R3. And we have given a ping, extended ping on R1 only.
Okay, okay, okay.
You know? So we are seeing the traffic throughout the routers.
Okay, okay. We-
Yes. Rahul?
नहीं सर, मैं यही कह रहा था कि हमने R1 पे एक्सटेंडेड पिंग लगाया है, लेकिन मॉनिटर जो कर रहे हैं R2 R3 के लिंक को कर रहे हैं,
Yeah, we can
तो वहाँ
monitor
पे दिख रहा
anywhere
है।
between R1 and R4. R4 will perform marking on their egress interface on F0/0, and it is going to identify the traffic. Classification is going to be happen on egress interface. Clear? And we have defined the toss value, but router has converted into DSCP because both are backward compatible. Right? If I will set class, let's say toss value 96. If I will select 96 here, 4.4.4.4, sorry, ping IP 4.4.4.4, repeat 1, size okay, timeout 1 second, extended yes, source 1.1.1.1, and here I am saying 96. What will be the class selector now? Tell me.
0, 1, 1.
Class selector value. Tell me the class selector value. Here is your chart. What will be the class selector? 3, 2, 1, 4. क्या?
4. 4, sir. Flash. 4.
4 was 128 bro. 3 होगा सर, 3.
96 means 64
No,
plus 32.
464 plus 4. Flash, na? P3.
011 सर, P3 होगा.
Yes.
3. Class selector 3. And see here. Done. And in the reply message, guys, if I will show you the reply message, here you can see for the reply message also, right?
Yes.
Okay.
It is not like only for request. Router 4 is also marking in the reply packet. So this is the reason why we are using differentiated service model. On the basis of traffic, we can give the priority. Right? Now let's configure the quality of service. Tell me where you want to configure, on which router? R2? R2 पे configure करें?
हाँ सर.
Okay, sir.
Okay. Config T. Let me create one access list first. Say IP access list number, IP access list extended and 101. Which access list I am using? 101.
Excellent.
Here I will match the traffic. Permit TCP host 1.1.1.1 destination host 4.4.4.4. Here you can select the subnet also in the
Yes, sir.
ACL, and after that equal to port number, let's say 23. That means I am talking about which traffic?
Telnet.
I'm talking about telnet traffic, telnet. Next. Next type of traffic is, let's say, SSH. So I will create one access list to match SSH traffic. IP access list extended, let's say 102, and here I am saying permit TCP host 1.1.1
Host
4.4.4.4 and equal to port number of SSH
22. So same access list में we could have done it, right?
नहीं होगा, देखो ना अभी आप ये यूज कैसे करूंगा मैं एक्सेस लिस्ट को.
Okay.
आपको अलग अलग एक्सेस लिस्ट के लिए अलग अलग DSCP वैल्यू सेलेक्ट करना है ना, डिफाइन करना है ना. You need to define different DSCP or IP precedent toss value for different ACL, for different types of traffic, right? Now I will create one more extended access list, IP access list extended 103,
3.
and here I am saying permit TCP host 1.1.1 host 4.4.4, and this time let me match any other traffic 80 for 80 or 443 means HTTP traffic, right? So I have created 3 route map to match traffic. First traffic is telnet, second type of traffic is SSH, and third type of traffic is HTTP. In the production you can have any traffic like this. Done. Now I will create the what? See the configuration step. Create the class map, right? So let me take you to here on the console, and to create class map, command is going to be very simple, guys. Class map, name of your class map, let's say name is telnet, name of my class map is telnet, and here I will match access group 101. Match access group 101 means I am matching which traffic? Telnet traffic, right? Then I can create class map, name SSH, and here I can match which traffic, which access group?
Access group 102.
102. I will create one more class map with name HTTP. इस क्लास मैप का नाम क्या दिया? SSH, okay. HTTP. IP access group, sorry, match access group 103.
3.
Clear. Now next thing is
Policy map.
this is done. Step 1 is done. Yes. Step 2, policy map. Let me create the policy map on .2. Policy map, name of policy map, for an example PMNet. Name of my policy map is PMNet, or let's make it simple, just PM. Just PM. And here in this policy map, what I will do, guys, I will match the class map. Class, and name of your class map is telnet. Name of my class map is telnet, here you can see, right? So I am calling that class map here, and then I will say set IP precedence value, right? What IP precedence value you want to set? Set IP and put question mark. See, DSCP is also there.
Correct.
Right, so we can match set DSCP value also or precedence value also. Both are compatible with each other, they will convert. So here I am setting precedence value what?
So question mark एक बार लगाइए please.
लीजिए, precedence value is here
0 to 7 precedence value.
right.
Critical
3 यूज करूं?
5.
3
3 हाँ जी flash.
3 यूज कर लिया क्लास मैप में. After
then
that,
one more.
exit. Now I will call another class map. Class map SSH, let's say SSH, and here I am saying set DSCP value. Let's say DSCP
अच्छा,
value.
ये कॉल कैसे क्या हमने वो करना चाहिए था ना, पहले बाहर निकलना चाहिए था तो
तो बाहर
पॉलिसी
निकला
मैप.
ना, एग्जिट किया ना यहाँ पे सर.
पी मैप में तो ऑलरेडी हैं हम. पीएम में.
पी
पीएम
मैप
में.
में है ना. देखिए सबसे पहले हमने
अच्छा, पॉलिसी मैप एक ही बनेगा. You mean
यस
to say.
पॉलिसी मैप एक ही बनेगा. एंड नाउ आई एम अंडर policy map, then under class map.
Okay, okay,
So I
got it.
exit from the class map and then I call to another class map SSH. Now I am under SSH class map, and under class SSH class map I am setting DSCP value for an example. What value you want to set?
4
Let's
you
say
can say.
EF.
4.
EF कुछ भी सेट कर लो.
नहीं, लास्ट वाली. ओके, चलो ठीक है.
SSH के लिए मैंने EF यूज कर लिया. And
मतलब
then
we can give a name as well as the
yeah,
value.
yes,
Okay.
then class SSH, the last one. Sorry, HTTP.
HTTP.
And for the HTTP, let me use EF value. Okay, so set DSCP. I'm saying for an example AF41. AF41. Clear? And then exit. Done. Got it, guys? What I did here. See. So policy map. So I have created one policy map with name PM.
PM.
In this policy map, I called class map telnet and I have set the precedence value 3. Then I called SSH class map and I set DSCP value EF, which is for voice generally. Then I called my HTTP class map and I set DSCP value AF41.
Sir, EF value not
Question.
mentioned.
EF value.
101.
Ah.
5 number.
So number
Sir.
5.
Yeah.
Yes, sir. What this command would do is AF41 में क्या value आएगा?
AF41 ये वाला. ये आपका EF कहाँ गया वो जो बनाए थे?
Yesterday class.
हाँ, yesterday class में हमने देखा था ना. Total how many AF we have, guys? AF
12
11 to 13. Then AF 21 to 23. Then we have AF 31 to 33. And then we have AF 41 to 43. So I said 41. Fourth column, first row.
Correct. Got
Class selector is 4 and drop probability is 1. Like that.
it. 4 means flash override. Okay.
Yeah. ठीक है. Now
ठीक है.
we can check so class map also. So class map. So you can see how many class map I have. I have 3 class map. One with name HTTP, where I am matching traffic from access list number 103. And in access list 103, I have defined the subnet and port number. Then in class map telnet, I am calling access list 101, and in class map SSH, I am calling access list number 102. And see, guys, there is one default class map also created, automatically created. Class map match any.
Okay. ID 0 is for
Default and match any. ID 0, this is the first class map. ID 0, then ID 1, you can see then ID 2, then ID 3. This is like the sequencing of class map.
Okay.
Right?
So default would be always ID 0. Huh?
Yes.
Okay.
Now we will apply it on the interface of router. On which interface?
Egress
interface. So go to config tree, say interface f1/0. And how I will apply? The
service policy.
With the help of service policy. So let me say service policy output and the name of your
interface.
policy map.
Okay.
Name of my policy map was PM.
Yes, sir.
Name of my policy map is, you can see PM, right? So let me say PM here. That's it. Now on router number 4, we need to enable telnet SSH and HTTP. Go to R4, say IP domain name, let's say cisco.com. Domain name cisco.com, crypto key
RSA.
generate RSA. Okay, default size is fine. Then I can create one user here, username, let's say admin, privilege, password is Cisco 123, or let's say Cisco only. Password is Cisco. Then line VTY 024 and login local. Right? Transport input all
telnet.
for telnet and SSH both.
Okay.
Now we can enable HTTP protocol also, IP.
Login local was for login local किसके लिए बताया था आपने?
Login
बताया था.
local means it is going to ask you for username and password both.
Okay.
Then IP HTTP server to enable HTTP service. Done. On router number 2, you can see everything is configured. So policy map, and on which interface I have applied? On interface F1/0. Here is your configuration. You can see the detailed configuration on interface F1/0. Service policy output PM and class map telnet, match all. Let's set precedence 3.
So match all क्यों किया इसने?
Match all मतलब?
ये ब्रैकेट में मैच
अच्छा,
all क्यों आ
match
रहा है?
all and match any मैं आपको बताता हूँ, रुकिए.
हाँ जी.
Sometimes it's match, like for all the class map which I have created, it's match all, and for the default you can see it's match any.
Any.
ठीक है, याद रखिएगा. अब verify करें. Let's verify it. How we can verify it? Capturing is already there. Now let me send some traffic from R1. Topology should be already in your mind, right? And I am expecting you know the topology. Ping
Telnet.
ping 4.4.4. First let me send ping 4.4.4 and source 1.1.1. See one more thing here on router number 2.
सर ये डिफॉल्ट में मैच हो जाएगा ना?
देखिए दिखेगा कहाँ से? यहाँ पे दिख रहा है.
हाँ सर, ट्रैफिक दिखेगा अपने को बेसिकली, kbps या कुछ दिखाएगा अपने को.
पैकेट
ये ऑफर्ड रेट करेक्ट दिखाएगा. एक बार आप पिंग करिए और रिपीट काउंट करके.
See in the service policy, guys, we are able to see which service policy is applied on the interface PM, name of your class map, and which ACL you have called here. If traffic will match, then it will set precedence value, whatever precedence value we have defined. If the telnet traffic is going to match, it is going to set precedence value 3. If it is SSH traffic, it is going to set EF, DSCP value EF, like that. And packet mark is, what packet mark is showing now? 0, right? So if I am going to send normal ICMP packet, where packet mark should increase? Default mein, right? So go to router 1 and let me send the ping. Let me say repeat 100, 1000. I'm sending 1000 ICMP packet, and go to router 2 and run this command. See here, packet mark is still showing 0, here also 0, and here also it's showing 0, right? That means till now no any match is here. Yes,
no traffic has been received for these classes.
Yes, or you can say router has not performed the any QoS marking. And here you can see packet count is increasing, right? Now let me send ICMP packet. Earlier here packet count was 36 and now it is 83, and now if you will check, that is going to be 507. So I have sent a 1000 ICMP packet, so you will have value of more than 1000 after some time. पिंग को स्टॉप नहीं कर सकते?
नहीं सर, 1000 इसीलिए
1000 कुछ ज्यादा ही भेज दिया ना।
सही करना था।
ठीक है।
अच्छा, इसमें पाइप इंक्लूड करके वी कैन नॉट चेक?
पाइप इंक्लूड करके हाँ कर सकते हो ना। क्या इंक्लूड करना है?
डिफॉल्ट करके डाल दीजिए ताकि अपने को सबका ना दिखे, बिकॉज वी आर नॉट
डिफॉल्ट
सेंडिंग।
डिफॉल्ट में तो ऐसे आ रहा है। डिफॉल्ट के
एक और पाइप इंक्लूड करके पैकेट्स कर लीजिए। इसी के आगे पाइप इंक्लूड पैकेट्स।
तो फिर तो वो सबका दिखाएगा ना पैकेट्स।
नहीं, डिफॉल्ट पहले, फिर पाइप इंक्लूड पैकेट्स। हाँ, पाइप इंक्लूड सर, एक और पाइप इंक्लूड, 2 पाइप इंक्लूड कर सकते हैं हम। हाँ, यहाँ पे पाइप इंक्लूड पैकेट्स नहीं दिखा रहा।
कुछ होगा, आप देख लेना, देख सकते हैं ऐसे। फिल्टर तो हम आउटपुट कर ही सकते हैं। ओके, डन। नाउ लेट मी सेंड टेलनेट ट्रैफिक फर्स्ट। टेलनेट 4.4.4.4 and then we can say what source interface loopback 1। ठीक है, username Cisco admin and password was Cisco. I got the access. Go to router number 2 and check your policy service. Sorry, not like this, like this. Are you able to see packet mark here 36? And even if you will open this telnet traffic here, you can see class selector value is 6, the same one which we have defined over here. IP precedence value 3. Here packet mark is still showing what, 0. Here for the HTTP traffic also it should be 0. You can see 0 0. So like this we can verify that traffic, like router is marking what precedence value or AF value or EF value. Traffic is matching in which class map. So
Telnet is routing protocol.
Telnet is a remote access protocol.
तो सर यहाँ पे फिर 110 प्रेसिडेंस हमने 3 लगाया था, करेक्ट? तो 6 वाला क्यों ले रहा है सर ये? हमने पोर्ट नंबर जो है एक्सेस लिस्ट में वो लिया था, प्रेसिडेंस वैल्यू 3 लगाया सर उसमें, करेक्ट? यहाँ पे ले रहा है 110।
तो सही तो ले रहा है।
हाँ, ये 110 सर, 110 इज फॉर मतलब DSCP, इसके
IP
IP
precedence value 3.
L3 प्रोटोकॉल के लिए है ना सर, इंटरनेट प्रोटोकॉल
हाँ
के
तो
लिए।
वही तो हमने यूज किया है। IP precedence value यहाँ पे देखिए क्या सेट किया हो, 3 जो राउटिंग प्रोटोकॉल के लिए वही हमने यूज किया है। We are using the same precedence value over here.
Okay.
Right. Now if I will send another type of traffic, let's say SSH on router number 1, now exit and SSH. क्या command SSH? How I can access router through SSH?
SSH -L
-L
admin
admin
4.4.4
4.4.4 username admin
Cisco
password Cisco। अच्छा password ही पूछ Cisco। Got the access and go to router number 2 and check service policy again on the interface, policy service, And see, this time traffic is matching over here.
पैकेट मार्क्ड
पैकेट
0 आ
में
रहा है सर अभी.
ये क्या हो गया, कुछ गलती कर दी क्या?
किया तो R4 पे आ गए हम लोग एसएसएच करके.
ट्रैफिक मैच नहीं हुआ.
एसएसएच का कहीं दिख रहा. हाँ आ रहा है, एक बार देखिए. एसएसएच वर्जन 1 एनक्रिप्टेड करके आ रहा है ना सर. 110. हाँ लग के तो आ रहा है सर.
प्लस
नहीं 110 करके आ रहा है सर. ये
110 यहाँ पे हमने सेट किया था AF
101 EF
101.
101 किया. करेक्ट.
ये मैच ही नहीं हुआ ना, ये डिफॉल्ट.
डिफॉल्ट में बढ़ रहा है क्या?
लग तो रहा है. config t IP SSH IP
वर्जन
SSH
2 वर्जन 2.
source interface loopback 1. अच्छा, source के वजह से. Got the point why it was not working? Because in the traffic, guys, source was what? In the SSH 12.1, the exit interface IP address. And in our ACL, we have matched source 1.1.1 to 4.4.4 only.
करेक्ट.
You are not configuring precedence value or DSCP value for all the traffic, right? So here we have to define the source. You need to run the command here, IP SSH source interface loopback 1. Now whenever you will SSH any device, it will use source 1.1.1, and then we can say here.
सर मैं R4 पे कर रहे हैं हम लोग ये सोर्स इंटरफेस सेट.
सॉरी, ये R1 पे होगा. config t IP SSH and source interface loopback 1. What it's saying?
प्लीज क्रिएटर. यहाँ पे क्रिएटेड
RSA
नहीं है सर आदत से.
crypto key generate RSA
And
domain name
please
IP
default
domain name
PM.
cisco.com, and then crypto key generate RSA. Okay, now we can run this command. IP SSH source interface loopback 1, and now let me SSH it. Now SSH -L admin and 4.4.4. Password is Cisco. Now I got the access, and now see on router number 2. Now here traffic is matching, right? Packet mark is 11. And in the capturing also you can verify it. You can see.
नहीं सर अभी भी पुराना ही तो नहीं है ये. 101 आना चाहिए अपने को. सेम है.
कैप्चरिंग में कभी कभी दिखाता है, गलत है. राउटिंग प्रोटोकॉल वाला ही ले रहा है ना, टेलनेट के जैसा. टेलनेट में दिखा, बट हियर वी कैन match it. Everything is working fine. Your router is performing the marking. It will set EF DSCP EF value if it is SSH traffic from the source 1.1.1 to destination 4.4.4. And here in HTTP, it's still packet mark is showing 0. So now I will send some HTTP traffic. How I can send HTTP traffic? To telnet 4.4.4.4, and I can use port number 80 here, and then source interface loopback 1. What happened? Loopback 1. It is trying to And now go to router number 2 and see. 3 packet mark is there, right? 3 packet mark is there in class map HTTP. Are you able to see, guys?
Yes, sir.
So my QoS is working fine, but here I am getting some error. Like here it's working fine. You can see AF value
41.
41. In the capturing, we are not able to see the value for EF bit only. Rest all the things are working fine. In the capturing, EF bit is not showing. For the SSH, it should be EF bit. But AF value is showing properly, and the IP precedence value is also showing properly in the capturing. Clear?
आई हैव ए क्वेश्चन। जब ये ड्रॉप आते हैं तो वो वहाँ पे ड्रॉप रेट दिखा रहा होता है
हाँ
पॉलिसी मैप में,
बिल्कुल।
दिस ड्रॉप रेट। तो उस केस में क्या होता है बेसिकली?
उस केस में अगर पैकेट राउटर ड्रॉप करता है किसी भी कारण से, जैसे इसका एग्रेस क्यू फुल है, तो वहां पे ड्रॉप रेट दिखाता है कि भाई ड्रॉप रेट क्या है। पैकेट ड्रॉप नहीं दिखाता है, ड्रॉप रेट दिखाते रहता है। ड्रॉप रेट कितना है उस पे, ये देखो यहाँ पे ड्रॉप रेट 0 bps. And guys, here I can have another requirement as well. Let's say I only want to configure QoS between on this link. Right? For an example, this is WAN link. This is your side 1, this is side 2. And on the WAN link only you want to prioritize the traffic. Otherwise, router 3 should forward the normal traffic to router number 4. Router 1 will send normal traffic to router 2. Router should perform marking, and router 3 should again perform demarking, and then it should forward normal traffic to router number 4. Is that possible? Yes, that is also possible. We can perform demarking on router number 3. What we can do? We can perform demarking on router number 3. Clear? Like it is going to be
Demarking on ingress interface or egress, sir?
demarking means what?
Yeah, demarking, yes, sir.
Demarking means removing the precedence value or the
precedence value.
DSCP.
Which interface we will apply, sir? This one exit interface?
On the
R3?
exit interface, yes.
Okay.
इनग्रेस इंटरफेस पे भी तो हो सकता है सर, ऑन द अदर साइड।
राउटर 3 पे जब वो ट्रैफिक रिसीव करेगा तब उसको डिमार्क करना चाहिए, जब फॉरवर्ड करेगा तब करना चाहिए। फॉरवर्ड करने टाइम में करेगा ना डिमार्किंग। मार्किंग कहाँ पे हो रहा है? इग्रेस इंटरफेस पे। डिमार्किंग भी कहाँ पे होगा? इग्रेस इंटरफेस पे। रिसीव करने के बाद तो सबसे ऊपर रिसीव करने के टाइम तो रिसीव कर ही लिया है ना इस इंटरफेस पे ट्रैफिक, मार्क किया हुआ ट्रैफिक। जब ये भेजेगा R4 को, उस टाइम में इसको डिमार्क करके भेजना है, नॉर्मल ट्रैफिक भेजना है। router 3 should forward normal traffic to router number 4. So we can do that like on router number 3 also. We can create one class map with name PM, and here I can say match IP precedence value what 3, and then match DSCP value EF, and then match DSCP value EF41 or 43. EF41, I think, right? 41.
41.
Let me verify it was. Yes, 41. Exit, and so class map. So see, in this class map is going to, guys, match IP precedence value 3, match IP DSCP value EF, and match DSCP value EF41. if it will only take action if all will match. Guys, first of all, tell me the difference between any and all. Match any and match all. What is the difference between match any and match all? In the ACL also there is option of match any and match all.
Sorry, any
Uh,
means
match
all protocols.
match any, it means you match everything. No, match all means you match everything, but match any
If you have
if
defined
is
any
going to
class
match
or
any other
ACL,
traffic that has not been
Let's say I have configured two rules on router. Two rules on router, and if I am saying match any, it means if any rule will match, then it is going to take the action, right? If any one rule will match, then it is going to take the action. And if I am saying match all, that means if both the rule will match, then only router will take the action, correct? Match any means if any one rule is matching, then router will take action. And match all means if all the rules are matching, then only router will take action. For any types of configuration, for ACL, class map, NAT, in the NAT also, in the NAT, let's say route map, we have set multiple rule that match IP address from this access list and match interface, match address from list number 100 and match interface F0/0, and let's say action is drop, and in access list number 100 I have any subnet 10.1.1.0/24. and now if I am defining here match any, it means either subnet will match or the interface will match, then it will drop the traffic. Or if I am saying match all, then if subnet and interface both will match, then router will drop the traffic. Yes or no? This is the meaning of match any and match all. And here in my case, router 3 will only take action if all will match. These all cannot match in any traffic. So here we have to create one class map to convert match all to match any. Class map and name match any to match any to PM, like this. And here we'll say policy map PM. Let me call the class map PM here, and I will say set DSCP default. That's it. And now we can apply it on the interface. This is how you can perform remarking. Remarking means removing the DSCP value or the IP precedence value. Now on the interface I can apply it. Interface F1/0 and service policy output, and the interface is going to be service policy output and name of my policy map was PM. That's it. Again from router number 1 you can send the traffic, and see I'm going to now capture the link between router 3 and router 4 also to show you. This is the capturing between router 1 2 and this is the 2 3, and this is the capturing between router 3 and 4. And now from router number 1 I am going to send again which traffic? Let's say HTTP traffic. Here it is. AF41 on router number 2 also you can verify that on the interface. And now let me show you the capturing between 3 and 4. And here is my HTTP packet. Now you can see. Default. Clear? So we can demark the traffic as well, right? Like let's say I have issue with bandwidth between router 2 and router 3 only. Here we have 10 Mbps link, here we have 1 gig link, here we have 1 gig link. So quality of service is not required here and here. Only it is required between router 2 and router 3. So you can perform marking on router 2 and demarking on router number 3. Let's say you are connected to service provider router. You are so talented network engineer, okay, and you are trying to send prioritized traffic over service provider network. Here is the service provider router. So what you will do, you will set precedence value or DSCP value. Let's say on your router, this is C router, customer is router C, and this is P, provider is, right? And after that, provider is connected to their another router, and somewhere you have another sites. And if you will think that, okay, let's do one thing, let me send prioritized traffic over service provider, so that service provider will forward my traffic first, because service provider is connecting so many customer. Can we do this? Yes, you can do this. On your customer is router, you can set, let's say AF value you have set 41 to prioritize the traffic. What service provider will do, guys, whenever service provider will give you the connectivity, whenever you are going to purchase the link from the service provider, they will create one ACL with IP NE. They have created one ACL with IP NE, source NE, destination NE, and then he will set what? Set DSCP default. लो, अब सारे कस्टमर का प्रायोरिटी यहाँ पे खत्म हो जाएगा, है ना? Customer priority is not going to work in the service provider network now. Even if you will send AF41 bit on traffic to service provider router will set it to default, right?
Yes, sir.
So that inside the service provider router network, so many routers are there, and these routers should forward default traffic only, right? So जैसे ISP के केस में आप देखो तो देखिए ISP एक एक्सेस लिस्ट कॉन्फ़िगर करके रखता है जिसमें सारे प्राइवेट IP को ब्लॉक करता है, right? Similarly, service provider will be using this command on their interface, right?
So on this case, what we can do, sir? It's not
You
possible.
cannot configure the priority of service. You have to increase the bandwidth. You have to talk to service provider. You have to pay for the required bandwidth, right? Or even service provider can also provide you the QoS service, that is called quality of service by provider, right? So you have to pay for that. Then the company, service provider company, is going to configure QoS for you.
Okay, sir.
Right? But by default, service provider will have this command on interface. So you can, there is no benefit of prioritizing traffic on my CE router. And here your QoS ends according to our syllabus.
So then,
There-
if I have, for example, sir, if I have a VoIP server inside my company, let's say I'm outside, then how to make a priorities this one? How to achieve this one for voice traffic?
I told you now you have to coordinate with service provider.
So only possible.
Yes. For the service, for the voice traffic, you can have a dedicated link. Right? So means whatever service you want to use, you have to pay for that. Right? Like it is not like this service provider don't know about the quality of service. If I will set priority over here on my C router, then service provider will process my traffic first. It is not like that. Clear? Now let's start IP version
सर एक
6.
क्वेश्चन है
हाँ.
पॉलिसी डिफरेंस बिटवीन पॉलिशिंग एंड शेपिंग सर कुछ पॉलिशिंग शेपिंग भी होता है सर इसमें ना
मतलब
टर्म होती है सर शेपिंग रेट देखते हैं हम लोग बैंडविड्थ कॉन्फ़िगर करने के लिए समथिंग लाइक दैट एंड पॉलिशिंग इज आल्सो देयर
hello guys. Hello, am I audible?
हाँ जी सर
Yeah, you are audible.
पॉलिशिंग एंड शेपिंग सर
Hello, Rahul. What happened?
आई थिंक वी लॉस्ट प्रफुल सर
Okay.
Hello, hello. Rahul, Karthik. Hello.
We can still hear you.
Yes, sir. You are audible.
Okay, okay. Fine. Yes, Rahul. Clear?
सर एक पॉलिशिंग एंड शेपिंग भी होता है सर
हाँ, होता है ना policing.
हाँ सर वो क्या होता है
Policing क्या
क्योंकि
होता
जब
है?
बैंडविड्थ समवन आस्क अस कि यार पॉलिसी बैंडविड्थ कितना कॉन्फ़िगर्ड है तो पीपल सी इट इन क्यूएस ओनली सर शेपिंग रेट देखते हैं
See, if the packet exceed to the allowed rate, then what will happen? What router will do? If the traffic is going to exceed the allowed rate, you know rate थोड़ा सा अलग है, then router will drop the traffic. If the packet will exceed the allowed rate, then router will drop the traffic, which is the default one. If you don't want that, you can configure what? Lower DSCP value to prioritize the traffic. Same thing we are doing here. Now, what is policing? Policing is like what we can say. Policy is like the drop. Policy policing is drops. And shaping can be, say, I can say shaping is like the buffer or buffer memory. Similar like it is exactly same your queue is called what? Shaping, where router is putting the traffic packet, right? So how router is arranging the traffic in the queue is called shaping. And you know the QoS means what? QoS means how router is going to put the traffic in queue. So in my case here I have configure QoS on router number 4 for 3 types of traffic. So this router is going to start maintaining 3 queues. It is maintaining now 3 queue, right? First queue for telnet traffic who have higher priority. Then one queue for SSH traffic. Then one queue for HTTP traffic. And it is going to arrange the queue in higher priority to lower priority sequence. And this particular thing is called what? Shaping. Shaping means how router is managing the queue buffer, their buffer. And policing means what? Policing means drop. Through shaping we can reduce the drop. What we are doing? We are reducing the drop on the router. यहाँ पे एक बड़ा अच्छा सा कमांड था. सो interface f1/0 rate limit एक बड़ा अच्छा कमांड होता है packet drop from the input queue, packet drop from the output queue. एक कमांड रहता है चेक करने का. यहाँ पे शायद नहीं है क्या? नहीं दिख रहा है. देखूंगा वो कमांड कभी मिलेगा तो.
सर शो इंटरफेस आउटपुट करके आता है सर. आउटपुट करिए एक बार.
आउटपुट नहीं हो रहा है ना. कहाँ है? कमांड ही नहीं है. शो इंटरफेस आउटपुट नहीं है यहाँ पे.
नहीं, शो इंटरफेस नंबर देन आउटपुट करके कमांड होता है सर.
हाँ नहीं, यहाँ पे नहीं चल रहा है ना. वही तो मैं क्वेश्चन मार्क पुट किया था. वो रियल डिवाइसेस पे मैं चलाया हूँ बहुत टाइम.
हाँ सर, वो फर्स्ट कमांड वही होता है सर चेक करने के लिए बेसिकली.
वो यहाँ पे अवेलेबल नहीं है कमांड. कोई नहीं. So this is basic QoS and hope it is clear. Now we'll move to IP version 6. Tell me today you want to start or next week?
सर नेक्स्ट वीक करेंगे सर.
फिर वीकेंड में ही होगा. ओके
हाँ सर.
सैटरडे को नेक्स्ट वीक में खत्म करते हैं टॉपिक्स. थोड़ा सा 3-4 घंटे के लिए कनेक्ट हो गया. 3-4 घंटे सैटरडे, 3-4 घंटे
What time will it be on Saturday?
Saturday this time 12 to 3.
12 to 3.
Yeah.
Okay. All right.